Alright guys, it's Novice and I'm back with another video. So this will be the final video in our password cracker series, unless, who knows, maybe in the future I feel like doing more. But this will be the coming together of everything we've been working on to finally build a password cracker that's like Hashcat. So with this, we're going to be taking what we built in the past from the SHA-1, MD4, and NTLM, and then the MD5 video, putting it all together so that we can actually build a password cracker that can find passwords in like a dictionary list and things of that nature. Now, a quick explanation of what this tool is supposed to do. Essentially, it's supposed to get hashes that you've somehow gotten from a Windows environment or any of the environments that I've shown or any of the hashes that I've shown, put them into this password cracker along with a dictionary list. It compares the hashes of that with the words in the dictionary list to find the actual word that you're looking for. So that is pretty much what this is going to be. And with that explanation, let's not waste any time and let's hop right into the video. So when I said to start right back up, we're starting right back where we left off. So with this one, we are going to essentially start off by commenting out the recipes so that we can have a blank slate. Who knows, maybe I'll need them in the future. If I don't, I'll just delete them at the end of the vid. Boom. Now next up, we pretty much have to create a main function. Now this is what's going to be called when we actually run this tool so that we can actually get the information that we're looking for. Yeah. So now what we're gonna do, and probably should have done this earlier, is import a class. There we go. Import a class called argparse. Now the reason that we're doing this is because it essentially goes through and creates the flags that are needed so that we can actually pull the information that we want to pull. So it might be easier to show you than actually explain it. So yeah, let's go ahead and get started. All right, we're gonna come here. Now we are going to use parser, hash a password using MD4, NTLM, SHA-1, or MD5. I guess that's essentially what's being done, kind of. But let's make the description like this, something a little different. That is perfect. Okay. Now essentially what we're going to do here is now we're going to create what are going to become the flags. So the first thing I think of is how exactly are we going to input our hash so that it will detect whether, or it will detect that hash and then compare it to the dictionary list. So in what I just said, there are two things to keep in mind: the hash and the dictionary list. So right now we're going to focus on the hash and how we are going to input. So when I think about this, I think about it in two ways. You can actually type out the hash itself, or you could have multiple different hashes or even a singular hash within a file that you want to actually parse through and see that compare to the dictionary list. So with that being the case, I'm actually going to create something that's called a mutually exclusive group. Now this is essentially going to make it so that either choice is true. As I just described, we can either have a hash or an input, a hash or a file with a list of hashes. So essentially what this is going to do is make sure that at least one of them is there. Not at least one of them, but only one of them is there. So either you input a hash or you input a file with multiple hashes. So we're going to call that the input group. All right. Now next up, essentially we are going to do what is showing on the screen, and we're going to essentially use this as the argument. So what this first one is trying to do is that it's essentially going through, if there's a flag with the word P or password, it's looking for that hash that we actually want. So let me actually change this. That might make it a little less confusing. Hash. I won't change this to H because if you guys use any sort of flags or have used any tools with flags, you know that the H is usually used for the help, which shows you exactly like what each command is supposed to do. So in this case, I'll keep it as -P. Now from there, we're gonna do the input group for the file. So add argument file. So instead of naming it file, because maybe I'll need to use the word file like for the dictionary list or something like that, I'll just call it input. Not input, input. Don't be silly. And then just to make our lives a little easier. Now, as we go through this, I want you guys to think of how Hashcat works. Usually going through with Hashcat, you have the option of choosing which type of algorithm that you actually want to use. So, like I said, we've now taken care of how or what is going to be inputted as a flag. We'll go ahead and do the logic a little bit. But we have what we need in that regards. We also need to have the algorithm chosen. In our case, for this list, it's very short. It's a very short list. These algorithms are going to be either MD4, NTLM, SHA-1, or MD5. Now, with that being the case, that is something that will also need another argument. And this argument will in the future be used as a flag. So, we're going to come here. Yeah, I like that. Except I want the words to be a little more short and precise, unless I can't do anything about it. So what we're gonna do is actually just lowercase these. So this gives you the algorithm that you're supposed to use. And I kind of skipped over this, but required is equal to true. This means that you essentially have to put these in the, you have to use these flags at least once. So with the input group, like I said, we made it mutually exclusive. So you either have to have the hash or the -p, or the input or the -i. Otherwise, this will not run at all. It'll actually throw an error that says, yo, you need to actually have this argument. Same thing with the algorithm, because if we don't know what algorithm we're using, we're low-key, we're cooked. We can't find the algorithm. We can't do anything if we don't know the algorithm, essentially. Then we don't know how we're hashing it, or yeah, we just don't know how we're hashing it. And if we don't know how we're hashing it, we can't hash the words that are going to be in our dictionary list. And because of that, we won't be able to actually find the password. Because like I said, the entire goal is to compare hashes to hashes. So the words in the dictionary list will just be straight up words, but then we'll go through and hash them using what we've already built out in the past. So moving forward, we're not done just yet. Like I said, we need 2 more arguments. So for me, like I said, I already explained the dictionary list. It's going to be the file that contains the strings that could be possible passwords. And I'm also going to throw in an optional one, which is just going to be an output file. So in that output file, you know, what you're going to do, say you have a whole bunch of words, a whole bunch of words in your list, a whole bunch of input words in your input file, and you want to have all this information stored in one place after the fact. Boom, you're gonna have an output flag so that it actually outputs the information to a file instead of coming to your terminal. So you're now going to actually build out that output. Oh yeah, look at that. Boom. So this is essentially all we need. Let me make sure that it's not required, because with the output, it's not really a requirement. It's just if you want it that way. And then finally, we're gonna add, if I could spell right, and this will be the final one that I add. And in my head, I could obviously come back to this project and add a whole bunch of different flags and to do different things. But right now, I want to build something a little simple to kind of get our feet wet, you know, so that we kind of know what we're doing a little bit. So let's go ahead, hit them with a -d, because this one is actually going to be a dictionary. -- dictionary. And we don't need that action.stores true. However, we do need that type of string. And then we're actually going to need this as required true. Because as I said, if we don't have a list to compare it to. Alright guys, had a little bit of technical difficulties. So I didn't realize this, but my mic stopped working a little bit throughout the video. So what I'm gonna do is I'm gonna kind of track back Well, you guys didn't even see it. So let's just hop right back into it so we can continue doing what we're doing. So boom. Here we've created a flag for the output file. Now we're gonna create a flag for the dictionary list. Now obviously this is important because the dictionary list is what holds the passwords that we think could be the password that's related to the hash that we put in the hash flag or the input flag. So this is what we are going to use to compare. My spelling is atrocious. But hit one of these, -D. It thinks we're gonna do display, but we're gonna actually hit them with the whoop-de-doo and hit them with the dictionary. If I can spell. We don't need the action to be that, but we do need the type to be a string, because the string will lead us to the file path that, as you can see in that help is actually very good description. But one more thing is that we have to require this to be true. And I'll actually tab that out so it finishes. So the reason that we need this to be true is essentially because if it is not true and we want to compare hashes, we have no possible way of doing that, like at all. So we do need a dictionary file because that's actually going to be what we're comparing to the hash value to see what the possible passwords could be. Now we can get into, I won't call it the real form, but we can actually get into the logic behind each of these flags. So as we go through this, I want us to kind of think of it in this way. Essentially, we want to utilize each flag so that they are each doing what we want them to do. So when I think about it in the bigger context, the most important part is the actual mutually exclusive group. Now, the reason I say that is because depending on those, we're going to be doing these in two completely different ways. Well, not completely different, but different enough that they should have two different sections. So what we're going to do here is create an if statement that determines whether we are talking about the hash flag or the input flag. So start that off. We go ahead and hit them with the if, and we're going to do that a little later. If args.hash is I'm moving a little too fast, guys. So essentially, before we even get to that step, we have to make sure that this args is set as well. Now, the reason that we have to do that is because this essentially gets us all the arguments as well as the inputs that people have used for those arguments. So this actually is very important. Now from here, what we're going to do is actually store. All right, look at this. It's kind of okay. It's just playing with me. So what we're going to do now is essentially store the hash because we know that the hash exists. We're going to do hash and then just equal it. So no, this hash is actually just going to be equal to args.hash. I'll go over the algorithm selector in a second because it is also a very important part of this. So this is what we need, and we will actually lower it as well. So the reason being this. So if you say you grab a hash that all the letters are uppercase, right? Now, what our class's output are all lowercase values. So what we actually need is for each of these things to be in lowercase. Because if you get a hash with, say, a capital A as opposed to a lowercase a, when we go through the logic of the following script, it's not going to match it as it's the same thing. It's going to say that it's different because in essence it is, when it's lowercase and when it's uppercase. So what we're going to do here is essentially take that possibility off the table by making everything lower. And then from here, we can get started. We'll go into what we got to do. So we're actually going to, so I'm going to follow this a little bit. Now, if it looks like it's a little too perfect, I will say, as I said earlier, there are technical difficulties. I did go through a little bit of this earlier, so it might just be copying what I already put before. So with that being the case, it's not really a problem. So we're going to hit one of these, and I'll break down what's happening here. So essentially what this is doing is that it's going through our actual dictionary list, grabbing each and every single line, removing any white space before or after it, and then getting the algorithm of that password. Wait, if algorithm select. Oh, okay. So it did a few things wrong. I thought it was copying what I did before, and I was stupid. So I'm gonna actually do it the way I did it before. So essentially, instead of password, I named it dict password so that we know that this is coming from the dictionary list. From there, I did something called dict hash, which does the following. Now we're gonna actually remove this lower because, as I explained before, these already come out in lowercase. So there's not really a need or a reason to do so. Now from here, we are going to change this up a little bit. Boom. So yes. And then instead, I want this to say match. I'm gonna make the changes, and I promise to you guys I'm gonna explain what's going on. So why is it doing that? Okay, so let me come back up to this dict hash because I feel like I was going on autopilot there for a second. So you guys might be wondering what this algorithm selector is. Like I said, technical difficulties, but I built out a function called the algorithm selector, and it is actually over here. So here it goes through the algorithm that we have put in here. Essentially, we want that to be the algorithm that was input by this algo flag, and then it grabs that algorithm, and then it actually hashes the passwords in the dictionary list in whatever format we have specified for it, and then it returns that into this dict hash. Now from there, we actually want to compare the dict hash to the actual hash value that we have to see if they are the same. If they are the same, we print. Wait, I'm moving a little too fast. I'm so sorry. Because I realized it also missed another key thing. So as I said, our goal is to actually use all of these flags to their fullest. Now, I want us to make a distinction between the output and when there is no output flag. Now, when there is an output flag, we want the information to be stored within the file. If there's not an output, we want everything to just be in the terminal. So we're gonna make a little change here as well because, like I said, I trusted the computer. I should not have done that. I thought it was copying what I did before. It obviously wasn't. So we're gonna do args.output, right? Now, essentially, we are going to, oh, whoops, stop playing around with me a little bit. I'm trying to work here. Sure, we'll okay this right now. Actually, we won't okay this. What I want to, please leave me alone. Stop, I'm trying to work. Okay, what I want to okay is this. So we're gonna do if there's an output, and if there is, if the hashes match, if the dictionary password hash matches the hash that we've actually have, we are actually going to, now we're gonna do the with open, yeah, that's fine. With open as out file, and then here we're actually going to copy this message here and paste it in there as well. Oh, actually, let me just do this because I do want to keep that new line character there. So we're gonna do this way instead. Come on, but boom. Okay, so now we have it so that it actually outputs what is written here into the file. That way you can determine what the password actually is, and then not even compare it. You have now the hash and the password, and you can use it to do what you need to as a red teamer or pen tester. Now from there, I also still do want it to say that, oh, the match was found on the terminal, but I also do want it to say that it was saved and saved to, and then we're actually gonna remove this, and we're gonna say to the args output. Okay, so this is exactly what we want to happen if it is true that the password hashes match, and this is actually just gonna show us what the password is and then place that into the output file. Now from there, we wanted to see, oh, what would we do though if it wasn't the password, but it was still in the, but we still use the output flag. So that's where this it else a little too far. So we're gonna use the else in here. Enter that bad boy. Now what we're gonna do here is essentially something similar that we did in the actual case where I did match the password, where we're going to open a file and we're gonna write a message. So I'm actually just going to copy this. Not the return though, because we don't need to return if we didn't actually get the password. Now what we're gonna do here is instead change the message. We're gonna move the password to the front. From there, we're just gonna say is not a match. And then boom, we have done our part. Now let's just change the let's just change this also in the bottom part, which represents what's actually gonna go on the terminal. So we're gonna move it here. Not a match. And then saved here. Boom. So we have essentially done what we need to do if our output is actually in play. So now we can actually get out of these and then do the else statement here. Now this else statement is essentially going to say or do sorry, it's chilly outside. It's been getting to me. But essentially what this else statement is going to be doing something similar, but it's going to be posting the output instead of in a file, just on the terminal command line, whatever you want to call it. So the results will actually show up there instead. So let me go ahead and read through this and see if it's actually doing the right thing. It looks like it is, essentially. So we're just going to tab this out. So essentially what this is doing what it happened in the output one, but in this case just here. It's going to check to see if the hash value that we have given it matches the dictionary password hash value. And if it does, it says the match is found, it returns, it's done. If not, boom, we do password is not a match, and it continues to go through the dictionary file to see if there is a match. Now essentially if there is no match found, you'll just won't see a match found in the terminal or in the file. So boom, we have now completed one portion, a pretty sizable portion of this password cracker, which is what to do when you're past a singular hash, right? So now what we're gonna do is if we are passed in an input file with a number of hashes, or who knows, maybe even one hash. So with that, we're now going to move from using this arg.hash flag to now using boom, 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 boom. Gotta check the line, see if it lines up there. Yes. So we're gonna head in with the else if arg's input is not none. And now we're gonna have ourselves a little bit of fun. So what we're gonna do here, or the first thing that came to my mind, was that boom, we can create an empty list. Then from there, we can go through the dictionary file, get all of the hashes and put them in a dictionary file list. That way we won't have to continuously go through each password once we're comparing them to see if the hashes match. In this case, we already have the hashes, we already have the passwords that relate to the hashes, and then we're just comparing the list comparing the new list of the dictionary password and the dictionary password hashes to our input file and its hashes. That way, I feel like it should save on compute power. I'm not 100% sure, but I'm pretty sure it should. But I might be wrong. I might be wrong there. So essentially what we're going to do here is create, well, let me name it a little something. And then we're going to make it empty. So this is a good way to start. Now from here, we're going to actually open up the, not input. Like I said, first thing I want to do is get the dictionary file, get all the passwords in there, and then the hashes as well, and then put them into this list. And then we will deal with the input file after that. But first, we're gonna hit them with the args.dictionary. Boom. And for this one, I actually just want to change this to dictionary. No, just dictionary. And then we're gonna come in here, do the same thing. Boom. And I think we should be good. Now, this is where I have to go through and review that this actually did it right, because me being overconfident in the past is what led to me missing a few of these things. So essentially it goes through, it grabs the password in the dictionary list, it strips it, it puts it into the algorithm selector, from there it gets the hash value, and then from there it appends the dictionary password along with the dictionary hash file, the dictionary password hash. Now this is exactly what I wanted to do. So, good job computer, you've done your thing right here. So this is perfect. Now from there, we can actually go into what we do with the input file. So we're gonna actually open up the input file, and let me see if this is actually doing what I want it to do. So for line and input file, input hashed dot strip dot lower. I'll be honest, I'm glad they caught on to that. Match found equals false. Match found equals true. I'll type this out in the way I want to, because this match found, I'm not really seeing a reason for it. I know it can be a compare, something to actually compare to see if it should do one thing as opposed to the other, but it also then does that in the bottom here and then changes it to match true. Let me know in the comments if that matters, because it doesn't look like it does any big changes. But whatever the case might be, I'm kind of going to type this out my own way. So for line in the input file, input underscore file. Now what I do want to do is what they have suggested here, and then that input. Now here is where it differentiates, because like I said, I generally don't think that's needed. This found equals false. It seems just extra for no reason to me. But like I said, let me know in the comments. I'm not exactly what people would call a conventional coder. I kind of code in the way that makes sense to me. So for here, we're gonna actually see for dict and hash. I'm gonna read through this one. Maybe it makes more sense to me, and maybe I'll just output this one. This makes sense to me so far, so I might actually follow exactly what this is saying here. So this makes a lot more. Well, it wasn't much different. It was just that found variable was really throwing me off. But essentially what this is doing, it's going through comparing each input hash. Let me double check that that's true actually. Yes, so it's comparing each line in the input hash to each of the words in the dictionary list, or their hashes to be more specific. And here it's specifying that, yo, if it is the argument output, or if the output flag is actually, if the output flag is actually used. I don't know why my brain couldn't think of that. We're gonna actually open up that file and then do as we did here, output file.write match found, and then we actually print it to the terminal as well. And in this case, it's doing something a little bit different than what it did at the top, but I'm not mad at it. So it's essentially saying to only do this in the case where everything matches. So the input matches, so the input hash matches the dictionary hash. Do the following. So from there, it just prints out this one when the output file is not used, and it actually matches, the two hashes match each other. So from there, it prints it just to the terminal, boom. My assumption is if we actually keep going, the next one will be an else statement that says else, and then has the same structure if args.output, and then it shows what happens if it is not, if these two don't match, essentially. So it'll say something along the lines of match not found, and then it's saved to the args.output. That is my hope. So else, no, come in a little bit, don't do that. There we go. Now be very careful with mistakes like that, because those are the mistakes that I despise. It's just like something little, oh, you spaced it out wrong and now everything doesn't work. Be very careful of that, because it's just very small, but it just sucks. All right. Now let me see. Oh, actually, one thing I want to change up here is the following though. I want to actually say what the input hash was and what password it matched with. Because like I said in the very top one, there was not really a reason to say, oh, your input matches this one, or your input matches this hash, like input 1 matches this hash because there's only one input hash. With this one, there could be multiple different inputs, and with that being the case, we want to specify what hash it actually matches with. That way it just makes it a lot less confusing for the user. So match found for, yeah, I'll do that, and then we'll probably do the same here. Match found for, yeah, I'll do it. So just tab that. All right, cool. Now, just got to keep that in mind for this bottom part as well. So let's see. If args.output, we're going to open the file and then write out in the file, this password is not a match for this password hash. That makes perfect sense to me. So there's not really much I have to change there. And then it does the same thing by printing it to the terminal. And then here, if the output file isn't used, essentially, this prints to the terminal, which is essentially perfect to me. So it says print is not a match for input.hash. Well, print dict password is not a match for the input hash. And that's perfect for me too, because it goes through the file, sees that, oh, it's not a match, it prints that out, as well as the hash that it is not, related to the password. So this is perfect. So essentially we're done here, and we just have to do what they're suggesting at this bottom part here. We're gonna hit them with the if name equals main, call the main file, or call the main, what's this called? Main function. Whew. Now I'll be honest, that was quite a bit. But now we've reached our final stage, and that's essentially just testing this out to make sure that it works properly. So in this part, let's go through here and see what we can test to make sure that it works. So we're going to test both the hash as well as the input. So we'll do those two separately. And then in the end, we'll also test that output. So let's do this. So first, let me hit this play button so I can see what I'm working with here. Okay, so as you guys can see here, this actually is very helpful. Like I said, we made a lot of things required because otherwise this essentially would not work. So the algorithm is required, as well as the dictionary. Wait, is this not required? Interesting, it didn't say it wasn't required. That's not good. It does show it here though, so I guess that's okay. So with that being the case, that's fine. So now let's actually get started on the real test. So we're gonna, boom, copy this. Let me think of how I can play this out. So what I'll do, I'll get a dictionary list that I have, move it. It's like a super short one of 5. We'll make it 5 words actually. Let's do this. Let me see. So I'll move here. Boom. Okay. So as you can see here, quick password list of random words. So we got password, hello, I love you, fire shot, and winter 2026. So that's what we have right now. When the time comes, we'll also create a file for the input file, but that's later, not now. So we'll deal with that later. All right. Next up, what I'll do, I'll actually grab a hash from a hash generator using one of those words that are in the list so that we can see how it actually goes through and picks it out. Now let me see. I'll be honest, it doesn't really matter which hash I use. So let's just do SHA-1. So let me find a SHA-1 password or hash generator. And then we're gonna generate the hash for, let's do fire shot. It's a little further down the list. It can show us what happens if it is not the hash. So we're gonna hash that here. You guys can't see my screen, but I'm going through this and grabbing the hash right now. Boom. Now we come here. Now we actually get to use our flags. So for the hash, we have it as -p. Boom. And that's the hash for fire shot. Keep that in mind. Now we're gonna do the algorithm. I believe I did SHA-1. So SHA-1. And then from there, we're actually gonna do the dictionary list. D. All right, now we're gonna essentially copy this file path, except the test part. paste it here, and then do dictionary.txt. Now, let's hope that this works. Okay, that's fair. All right, so what I'll have to do instead is this. I'll be honest, I forgot there was a space in here. So I'll do this, boom, boom, and then we're gonna have to add, boom. Okay, so I'll be honest, I don't know what's going on right here, but essentially it does go through each one of them. It says that password is not a match, hello is not a match, I love you is not a match, and then finally it found a match in Fireshot. So this works properly. Now I'm going to get the hash of Fireshot, but with a capital T at the very end, and then compare or run that again so that we can see it go through everything and say that everything is not a match. Just gotta verify that this all works. Okay, yep, so it shows and goes through every word on the dictionary list and says that all of them are not a match. So this is perfect. So we now know that our hash flag works, our algorithm flag is working as well, because it was able to determine that Fireshot is actually the hash, and our dictionary file is working as well. So now what we want to do is test out our output with our regular hash, and then from there we're going to go completely into our input file. So let's do that now by adding this O. Let's go ahead and copy this right here. You'll see that bad boy. And then instead of dictionary.txt, we're gonna put results. Then enter. Now if we come here and open the results, it shows that there are no matches. Now we're just gonna, for fun's sake, we're gonna make sure that Fireshot is, we're gonna put in the actual hash for Fireshot, and then we're gonna try that again to see when it puts that match in the file list. But I guess a bad thing about this is that each time in the beginning, we'll have to delete this list essentially, and then recreate it, or use a different file. That's not the worst thing, but it could get annoying in the future. It might be something to play around with a little later. But right now, we are focused on the task at hand. Okay, now let's see what's going on in the results. Boom. So it goes through everything, tells us what's a match, and then finally, well, tells us what's not a match, and then finally shows us, oh, Fireshot is a match. Then it doesn't even do winter 2026 because we don't really need it because we have a match right here. So let's go ahead and delete this because we'll probably need you a little, well, we'll probably need to use you a little later. So now we are certain that hash, algorithm output, and dictionary work. However, now we're gonna move over to input and see how those work with the input one. So what we're gonna do now is create an input file. Let's do it. So we're gonna come in here. I believe we can create a text file from here, right? Cool. Just call it input.txt. Now we have the hash for Fireshot somewhere here. Boom. We're gonna use the fake hash for, well, it's not a fake hash, but it's the hash for Fireshot with the capital T. Put that in here. And now what I wanna do, I wanna add one more of the words that were actually in here. So let's do I love you. Okay, and now we're gonna save this file, come back here, and now we're gonna run through this again. Now, like I said, well, let's actually want it to be clear of everything except the necessities. So, yep, SHA-1, dictionary file. And now instead of P, we're gonna use H, or I said H, I. And now we're gonna actually copy this, come back here, delete all of these, paste that in here, and then change this to input. Okay, now as you can see here, we didn't do any output, but this is what we got. So hello is not a match for this hash, I love you is not a match for this hash, and then match found
fire shot. Okay, I don't like how they're doing this. Okay, so essentially what I wanted to come out is for its, oh, maybe I didn't change it in somewhere here. So we got to go back into our code. I'm sorry, my mind is blanking right now. Into our code to actually see where it says this match not found. Because what I wanted to do is to say that the match is found, but to show fire shot as well as the hash, because it can be confusing with all these different hashes. So I just wanted to say this password matches this hash. So let me find out where this happened. So our input. So we're here. Oh, I see it right here. Okay, so we're gonna copy this and actually place it down here as well. That makes our life easier. Yeah, I didn't see this earlier, guys. Sorry. Boom. Let's go ahead and save that, but let's check if it does the same thing down here. Okay, boom. So let's do this again, and then see if the results are different. Okay, perfect. So as we go through this, we see, oh, this is not a match for this hash. This is not a match for this hash. But we come down here and see that, oh, look, this is actually a match for Fireshot. Now we go through the one that ends in AA3. Now it should say that there's not a match for any of them. And I do this to specify, especially with Fireshot.
This was the same word, but with the T capitalized as opposed to the lowercase. So this shows that our hashing mechanism is working because it is genuinely disregarding something that should essentially be a match. And then finally, we have it here as well, where it's matching for this final hash value, and it gets I love you in the end. So it looks like that's working properly. So now we have something else checked off the list. So let's go back up and we can compare. So hash is completely fine. We went through it. Everything was working fine. Now we're on input. Now input works with the algorithm as well as dictionary. Now the final thing we have to do is make sure that it works with the output file as well, and we are good. So we're gonna hit them with a -O, and we're gonna ask it to do the same thing. Now essentially the only difference is that this should be stored in the password, or not the password, in the results.txt. And for me, I even still had the information posted in the terminal, but it's just so that we know what's happening essentially. All right. So here it even tells you that a match was found, but then you'll have to go into the actual file to find it. We can edit that as well, but this isn't that big of a deal as long as we do see the match here, and that is what matters to me. So essentially we should see the exact same thing. So we have a match for Fireshot. We have no match for Fireshot with the capital T at the end as opposed to the lowercase t. And then we have the match for I love you. So it looks like this password cracker is working properly. Whew. 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 Now guys, we put in a lot of work and had a lot of great fun. Hopefully you guys enjoyed building your own password cracker. For me, it was a blast. I got to find out about a whole bunch of different hashing algorithms. I got to actually think the way a coder or a hacker thinks with building out tools, as well as actually getting information in the way that I want to get it. And then finally, I was able to actually build out a password cracker that, although it's not exactly like Hashcat, it is similar in nature, and it is giving me it's pretty much giving me an idea of how Hashcat works and how I can use it then in the future in probably a better, or I won't say better, but it gives me a more knowledgeable stance on how it works and hopefully how to use it in a better or different way. But that's it for me, guys. Hopefully you guys enjoyed this series on how to build your own password cracker. Hopefully I see you guys in the future, because there are going to be some more tool building, some more red teaming, pen testing things that we do. So hopefully you guys come, subscribe, like the video, and like I say, if you don't like the video, let me know why. Still hit that like button after the fact, but let me know why you didn't like it so I can try to make the changes that are needed so that we can continue to improve our content. Well, that is it for me. It's been a long day building out this password cracker, but we have done it. But I'll see you guys in the next one. Novice out. Peace.